All right, everybody, we'll resume with the next reverse pitch. So next, please welcome Cassie Tran to the stage. Cassie is a senior licensing associate at the Children's Hospital of Philadelphia. Every day at CHOP, they get to work on giving every child hope for a healthy future. From life-changing research to leading clinical care, CHOP advocates for and provides the best for children in our backyard and around the world. So please join me in welcoming Cassie to the stage.
Hello, everyone. My name's Cassie Tran. Thank you for the introduction. Today, I'll just give you a little it's very tech transfer centric, the talk I prepared. Give you a little insight into our office, a little bit about some interesting research that's going on at CHOP, and some technologies that are available. No one taught me what to do. I'm going here, green button. Okay. So you may all be very familiar with CHOP. Here's a bird's eye view of the West Philly campus in all of its glory. We have both the clinical side and the research institute side. Our main hospital is located in the West Philly campus, and in 2022, we opened another inpatient hospital right here in KOP, and it's right across the street. You might have seen it coming in. In total, that gives us 667 beds, probably one or two more by now at this point. Oh, I'm sorry. There we go. Okay, we're good now. Of course, we have an enormous footprint on the clinical side, over 50 plus care networks with 17 specialty care centers and 30 primary care practices. On the Research Institute side, we have great work that goes on over in the West Philly campus. Bringing in, this is an FY23 number, $365 million in external funding with $680 million in total research spend. On the West Philly campus, we have about over 1,000 principal investigators there in over 638,000 square feet of dedicated research space, and that space is ever growing. As you may see if you ever come into the city, there's always construction over at CHOP. And as many of you may be aware, CHOP IP did go into some of the first FDA-approved cell therapies for cancer and gene therapies for congenital blindness, commercialized by Spark, as many of you are aware. Just to highlight some of the unique centers of emphasis at CHOP, under which the Research Institute is divided into. You can see, I'm not going to read them, you can see for yourself, but just to highlight a few, we have the Center for Mitochondrial and Epigenomic Medicine, that's led by Dr. Doug Wallace. We have the Center for Applied Genomics, which is led by Dr. Håkan Harkinarsson, and a foundation of that center is actually the CAG Biobank, which we'd like to highlight. It has over 600,000 pediatric biobank specimens from which our researchers can sequence and learn. Core facilities at CHOP that are available for our researchers. I just wanted to slap this slide up there to actually highlight, aside from the typical resources that are available to investigators, such as, your high throughput screening cores, your flow cytometry cores, we have some really unique resources available to our investigators. The CVC Clinical Vector Core, as you see in the corner of the slide, this is actually a CGMP compliant AAV and lentiviral manufacturing facility that's on the West Philly campus. It's located in the Colquitt building. This is available to our investigators. It really forms a cornerstone of some of the great research that's being done at CHOP. So getting into kind of what we see at the Office of Technology Transfer, we handle both disclosures that come in through the hospital side and the Research Institute side. By the numbers, I would say we average around 100 disclosures per year. This fancy chart on the left is FY22, 23, 24. What does that look like in terms of actual US patents filed per year and issued per year? We file around 40 US provisional patents per year. We file about 40 or so non-provisionals per year. And 16 to 17 US patents get issued per year. I didn't put it on the slide, but in terms of international applications, that comes in at around 100 filed per year and average 100 issued per year. So we're seeing a lot of volume. Importantly, in an ideal scenario, we get these licensed to companies to get further developed. For the FY24 number, I pulled 25, and these are specific either license or option agreements. This is about average, I would say, year over year in recent years, with 3 of those going to newer early stage startups. So what types of technologies are created here at CHOP? It may come as no surprise. Pulled this data from our database. The largest types of technologies that we see are therapeutics, followed by software, medical devices, diagnostics, research tools and reagents. Gene therapy and gene delivery obviously can go into the therapeutic category, but this is just how the data kind of sorts itself. We also see processes and copyright technologies. So you see it really runs the gamut when it comes to technologies that are helpful for improving healthcare. To break it down to kind of, what technologies actually get transacted, it follows the technology categories that we actually have. So this is data looking at the categories of technologies that are under our exclusive licenses. You can see therapeutics makes up the largest percentage of the largest amount. These are actually numbers, not percentages. The largest amount of deals that we do, followed by medical devices, diagnostics, software, processes, research tools and reagents. This all, not really surprising. But I'd like to kind of say that, at the Tech Transfer Office here at CHOP, not here at CHOP, but at the Tech Transfer Office at CHOP, we really take a flexible approach in kind of dealing with industry partners, potential licensees. It's a case-by-case evaluation. We all have the same mission, and that is to take these taxpayer-funded technologies and get them out into the marketplace. So I love my job. I love doing what I do. So with the remainder of the time, I thought I would just kind of highlight some really great PIs that are doing awesome work at CHOP. Some of you may be familiar with Bev and her work. She's a professor of pathology and lab medicine at CHOP. She's the director of the Center for Cellular and Molecular Therapeutics. Her work focuses on genetic diseases that affect the brain. She mainly focuses on rare diseases, such as the ataxins, Huntington's, Fragile X, lysosomal storage disorders, the CLNs. And the way she goes about this, the modality that she typically is using is actually AAV. So her lab continues to develop these novel AAV capsids that have unique transduction profiles, along with other tools that regulate and fine-tune gene expression. So I won't read word for word these technologies available for licensing, but if you see something that piques your interest, please reach out at the end of this talk. More than happy to kind of share everything that we have. But you can see she's got technologies available in Fragile X, in Huntington's, MPS III, and she's great to work with. Another PI, Nick Skarakis, he's an associate professor in the Center for Computational and Genomic Medicine. He also has an appointment in the Department of Biochemistry and Biophysics at Penn. His lab is really an immunology lab. It's kind of all things T-cell receptor peptide MHC binding. And he kind of interrogates this space using biophysical techniques like NMR spectroscopy and X-ray crystallography. Important questions that they're kind of looking at, relevant to industry. How do CAR-based therapeutics recognize their targets on the cell surface? What triggers T-cell receptor activation at the immunological synapse? Some technologies from Nick's lab that are available are listed here, mainly focusing on, how can we interrogate the T-cell receptor binding to peptide MHC. Dr. Stefano Ravella is our last PI that we'll be highlighting. He's a professor of pediatrics and an endowed chair in pediatric hematology. His lab really is using lentiviral vectors to modulate gene expression and gene transfer in a number of hemoglobinopathies listed up here. You can feel free to read the slide. I wanted to highlight, in terms of Dr. Ravella's available technologies, that this technology that you see here, the CHOP ALS 20, is actually recruiting and enrolling patients for phase 1, phase 2 study. You obviously can read it. This is a study in adults 18 to 35 with beta thal who require regular red blood cell transfusions, and they're going to evaluate the efficacy, the safety and efficacy of the IP right here, available for licensing. So yes, please, if you see something of interest, come meet me after the talk. Looking forward to meeting some of you all. My talk is short and sweet, 8 minutes, okay. I'll just end with thanking everyone in our office. Look at our small but nimble group. The licensing folks, directors and associates are on the left, and then the people that keep everything going, the accountants and compliance and paralegals are on the right. Zev didn't make it onto the slide. I don't know why, but he's over there, and many of you all know him. He's the VP, our fearless leader. So yeah, that is CHOP, OTT in a nutshell. Thank you very much. Look forward to meeting many of you.